artificial satellites have progressed from glory to space garbage. Before 1957, the space around the Earth remained pristine for billions of years. Then came the objects numbered 1 and 2 in the NORAD list, Sputnik 1 and the rocket used to launch it by the Soviet Union. Sputnik circled the Earth in an elliptical orbit, but at such a low height that atmospheric resistance drove it to fall after 3 months. The following year, NASA launched object number 4, the Vanguard 1, but contact was lost. It still rotates around the planet after drifting since 1964. Sputnik and Vanguard were the symbols of a grandiose technological achievement at the height of the Cold War. They are now nothing more than junk, space garbage. Since 1957, humanity has launched almost 10,000 satellites into space. All but 2,800 of the remaining active satellites no longer exist or are inert and cold in orbit. Some, like Sputnik, are destroyed. Thousands more, like the Vanguard, will remain in orbit for decades or centuries, circling the globe like ballistic debris, posing a continual threat to astronauts and their spacecraft. The Cryosat-2 satellite was orbiting just over 700 kilometers above the Earth's surface on July 2, 2018, as it had been for years. But on that day, the European Space Agency's mission controllers realized they had a problem, a space debris of unknown origin, but whose orbit had previously been tracked by radar, was heading uncontrollably towards the $162 million satellite, which had been in orbit since 2010 to monitor the extent of the polar ice caps. As the engineers followed the paths of both objects, the likelihood of a collision increased until the danger threshold was reached, requiring the controllers to make an immediate choice. As a result, on July 9 at 9:22 TU, the order was given to momentarily activate the secondary engines in order to propel the satellite into a higher orbit. After slightly over a half hour, the debris passed 120 meters distant from the satellite at a speed of 4 kilometers per second. Without the modification, it would have passed at less than 14 meters, putting the pricey cryosat equipment at danger. A common intervention for people on Earth who monitor conditions that could lead to a satellite colliding with other satellites or tiny bits of what is now known as space junk. The area around the Earth, particularly the so-called low orbit, up to 2,400 kilometers in height, is becoming increasingly congested. In 2019, commercial businesses, military and government agencies launched nearly 400 satellites into orbit, more than 5 times the annual average from 2000 to 2010. As previously stated, around 10,000 satellites have been launched into space between 1957 and present, with 2,800 currently operating. 232 of these are in low orbit, whereas 560 are geostationary at an altitude of 36,000 kilometers. Thousands of now extinguished and adrift satellites, enormous shipwrecks of booster rockets, and numerous smaller objects formed by wear, collisions, or explosions, such as bolts and other metal bits, join those still functioning. And definitely stranger things, like Elon Musk's Tesla Roadster, with a dummy behind the wheel and the urns brought into orbit by Celestis, the space funeral home, the ashes of Gene Roddenberry, the creator of Star Trek, as well as astronaut Gordon Cooper, are among them. Not to mention the items that astronauts unintentionally dropped during spacewalks: a camera, a spatula, a glove, a mirror, and a backpack full of tools worth $100,000. The NORAD military tracks approximately 26,000 items in orbit around the Earth, but the database only contains information on objects larger than 10 centimeters. The total number is significantly higher. According to NASA's Orbital Debris Program Office, there are 100 million millimeter-sized fragments and 100 trillion 1-micron-sized bits. We live in a garbage crown. Donald Kessler, an astronomer employed by NASA in the 1970s to examine asteroid collisions, was the first to recognize that space pollution is a major source of environmental damage. Throwing himself into the project, Kessler realized that NASA's current attitude toward orbital debris was based on an incorrect assumption that the only artifacts to be concerned about were those in the NORAD list. In fact, the experts decided that the smaller particles could be ignored in the calculation of the probability of collision. Kessler, on the other hand, was well aware that very small objects were far from insignificant. According to his estimates, even a little component might have ripped a satellite apart, dispersing a cloud of debris in all directions. And he was well aware that if the population of items was dense enough, collisions would start an endless chain reaction. The shards would become smaller and smaller until they resembled sandstorm grains, a nightmare scenario known as Kessler's syndrome. The technique would eventually render all space near Earth worthless. In theory, our planet may get a ring comparable to Saturn's, but made of rubbish, Kessler speculated. Kessler published in Side Note in 1976 that examined 3 scenarios based on the number of satellite launches in the future. In the realistic scenario, he predicted that collisions would begin within 15 years and that by 2020, some orbital zones would be so dangerous that no satellite could operate for more than a decade. Kessler was simply wrong when he anticipated that the situation in low orbit would be jeopardized by 2020. We are not there yet, but we are on our way. And the forecast could still come true if firms like Boeing, OneWeb, and SpaceX carry out their ambitions to launch hundreds to thousands of communications satellites into space over the next few years. After all, remember how a powerful first indication was present a few years ago? On February 10, 2009, 2 artificial satellites collided at a height of 790 kilometers in the skies above Siberia, being destroyed in the collision that happened at speeds well over 20,000 kilometers per hour in a statistically predictable but still nearly inconceivable incident. The Russian Cosmos 2251, a decommissioned Russian Army telecommunications satellite launched in 1993, was the investor. The investee, the considerably more modern and pricey Iridium-33 satellite, was one of 66 belonging to the well-known global commercial telecommunications network. The impact created a cloud of thousands of fragments, only 100 of which, the largest, can be traced and constantly watched in their motions by the NORAD surveillance system. Although the event's dynamics appear strange and, in some ways, suspicious, it appears to have been an accident. The Cosmos had long since ceased operations, while the Iridium, despite being gifted with a maneuvering system to change the orbital attitude, was unable to recognize that he was on a collision course. The most concerning aspect is that neither NORAD's military surveillance system, NASA's Orbital Debris Program Office, nor other surveillance systems on possible impacts with space junk had minimally predicted the impact. In fact, the 2 satellites were predicted to be 485 meters apart at the time of the collision. The problem is that the effect of the sun's radiation pressure is felt by relatively small objects, capable of both changing speed and orbital configurations in an unforeseen manner, as well as partially modifying detection systems, making safe surveillance problematic. 100%. Every day, NORAD provides an average of 21 alerts about probable collisions with debris larger than 10 centimeters in diameter, but hits with small fragments happen all the time. They are one of the causes of the degradation of solar panels, which are slowly but inevitably affected by particles, a speck of dust. Obviously, researchers are investigating new technologies to address the issue. To clear or divert junk into orbit, some use massive magnets or lasers blasted from the Earth's surface. However, given the vast number of objects to be deleted, such approaches are unlikely to be useful. Nonetheless, a fresh orbital calamity is becoming increasingly inevitable. Mega constellations of satellites, such as Elon Musk's Starlink, are being launched into orbit. At the current rate, there will be 50,000 new satellites servicing the internet in 10 years. As a result, it is a potentially explosive problem. What can and should be done to avoid it? The first step is to persuade various countries, primarily China, Russia, and the United States, to take the bare minimum of measures to avoid the production of space debris, namely, to re-enter satellites into the atmosphere at the end of their operational lives, causing their destruction at the most within 25 years of life, or to push them into extremely high orbits. To avoid explosions, dump the rocket tanks in a systematic manner once they have completed their mission. However, some governments do not even take these basic precautions. Since 2002, the Federal Communications Commission has also required that all satellites placed into geosynchronous orbit have a mechanism of being pushed into a higher orbit, a form of graveyard where they can be housed when their operational life is up. However, according to a 2005 research, just 1/3 of the governments who owned these satellites actually followed this requirement. A 2013 economic study proposed an intriguing proposal, requesting a fee for each launch to pay for space debris cleanup. However, these approaches present significantly greater political than technological challenges. To adopt any cleaning mechanism, further changes in international law would be required. For now, even satellites are considered private property, and owners must provide express permission before anyone else can touch them. Even when the regulations are in place, enforcing them might be tough. The scientific quandary is that there is very little relevant knowledge on the potential scope of the problem. The political conundrum is that mitigation measures do not provide instant quantifiable results and can take decades or centuries to produce tangible advantages. Fortunately, even a tiny expenditure, a fraction of the millions required to develop and launch a satellite, if used wisely, could be effective in minimizing the effects of space debris. Perhaps no other human endeavor will require such a wide range of scientific, technical, practical, and legal skills. How we handle this challenge may have a significant impact on the increasingly complicated difficulties confronting the human community. Satellites and related space operations are vital to the global economy, with yearly revenues of around $80 billion. They are crucial to global security and sustaining our quality of life through everything from spy satellites to satellite TV. Whatever the next steps are, they will very certainly necessitate considerable international coordination. Indeed, no nation or sector has the capacity to reduce the risk of orbital debris, let alone secure its space interests. Alright everyone, here's where the video ends. Thanks for watching, and don't forget to like, share, and subscribe.